So sound and vibration are at the core of all of life. And so I want to talk a little bit about animals and plants. So Ed Young, who wrote this wonderful book, An Immense World, says, noise is the pollution of disconnection. It detaches us from the cosmos. It drowns out the stimuli that link animals to their surroundings and to each other. So it's not just humans, it's all living things. In making the planet brighter and louder, we have also fragmented it. Okay, so here's some science. How do animals deal with this? Well, birds, the noisier the environment, the higher the pitch the birds will sing at, which necessitates higher metabolical demands. The higher the pitch, it's harder to be heard because higher pitches don't carry as far. So the birds just, they alter the songs they sing when there is noise. And in a study that was done in France where they looked at sounds that of the animals the birds in a forest preserve next to a highway, and compared the songs on weekends and during the week when the traffic patterns were different. And they found that even in these short term, within a week, the birds they're listening, they're interacting with their environment, and they are altering their song, which is hugely important for everything they do. In the pandemic, we all noticed that the birds, the birds actually, for people who measured it, were singing more quietly than usual. We thought, we could hear it because there was much less noise, which of course was part of it, but they actually, decibels, they were singing at lower, quieter decibels, and they were able to sing more intricate songs, which is really important because male birds sing and the female birds listen and choose, and this allowed the male birds to be much sexier. So, we don't often, it's bad enough that we don't notice sound out here in the air, but there is sound and vibration underwater that carries very far, and every single animal, every fishy, every organism in the sea is affected by these vibrations. And so, there have been studies done in whales finding that they will make their productions, they will become louder and louder and louder as the noise, as the turbulence increases, until it gets to a certain point and they become silent. But ordinarily, whales communicate to each other over hundreds of miles. Isn't that cool? And we're messing up that. So
they can be deceptively still.
That's the weird thing. You don't hear anything and you think they're doing nothing. They're boring.
But this seemingly peaceful world where insects scuttle across plant leaves is far from tranquil. Out of range of human ears, tree hoppers are making a racket.
This is not sound. We can't hear it. Yet, the animals are busy communicating with one another.
Tree hoppers communicate using vibrations they make with their bodies.
They kind of hitch up their abdomens and they lock their legs and then they vibrate their abdomen up and down.
The vibrations travel through the plant and are picked up by sensory nerves in the legs of other tree hoppers. They're known to use vibrations while foraging to find mates and warn others about predators.
So
we can't hear these vibrations, but researchers can translate them for us. By bouncing a laser beam off the vibrating surface of a stem, they can measure the frequency and amplitude of the movement.
And then you play back that signal.
So, I mean, did you even know? I mean, this stuff just blows my mind that there is all of this communication with sound from insect to insect and from insect to plant. So the plant will know because the plant also has vibration receptors, and the plant will know if there is a very hungry caterpillar around. How many people know that reference? That is going to be bad for its health. And so the plant then will begin emitting certain hormones that will protect it. So when we vibrate the world, when we make noise, and moderate level noise really gets it. I mean, these vibrations are so tiny, they almost defy the laws of physics in being able to pick them up. But they've been doing this for years. It's just us that have just discovered yesterday. So trees also can make sounds and be sensitive to sounds. This is the pando tree, one of the largest trees in the world, and with tiny little microphones within the tree, some sounds have been recorded. And this is what happens within the tree when there's a fox walking by. So again, we can't just hear these sounds. We can measure these sounds and we can transpose them into sounds that we can hear, but this is going on. So every plumber knows that tree roots are going to make their way into your pipes, right? And this is because the tree roots actually respond to the sound of water. So, you know, we know that roots will grow towards water when the water's in the pot, because they need water. But they will also grow towards the sound of flowing water when the sound is outside of the pot. And they will not grow to other sounds, or they will not move towards other sounds. It's the sounds of water, which again is really important. This is in another study where they measured the percentage of roots that were moving towards the sound of the water. And, you know, animals, as people, we are all tuned. We are all specifically tuned. And so the roots are tuned to specific frequencies. It's not just any frequency. Flowers are tuned to specific sounds. So it turns out that the flowers will release their pollen only when a bee will come around that is buzzing at the proper frequency. So the plant is that sensitive to these frequencies of vibration. So, you know, otherwise they'd be throwing their pollen all over everything, but it's the specific tuning. Sound in coral reefs. We know that they're waning, and to have a healthy coral reef, you need to have fish around it, right? And what scientists did is they put loudspeakers of the sounds of fish near the coral reefs that were failing, and found that just the sound of other fish and other organisms brought fish to the area and onto the coral reefs.